welcome to this session. This is the kickoff of our hackathon with Concordium on techFiesta. I'm super happy to have Doris here today with us. She's from the Concordium team. And today with Doris together, we'll introduce the hackathon, what you guys are going to be building. And Doris will also introduce Concordium, say a few words about the Concordium Foundation and the tech stack Concordium is using, what use cases are currently built on Concordium. And we'll, of course, gonna answer some questions from you guys. Of course, I want to first share a couple of slides, which will be mainly about the administrative part of this hackathon. But of course, this is also very important information that you should know. Today we have the information session and an engineering call together with Doris. And the agenda for today is that I will briefly introduce EcoLens and our platform techFiesta. I will also introduce the hackathon and what the hackathon is about, how you guys can submit your results for the hackathon, and then we will speak about Concordium, and you will have the chance to answer questions. All right, so we at EcoLens upskill professionals and connect them to work opportunities in the Web3 space. And for this, we have built our platform techFiesta. What we do through techFiesta is upskilling workshops and educational sessions on technical topics, non-technical topics, and soft skills. For example, we had a Rust training, again, together with Concordium last year, where it was a workshop of about 3 hours, where we gave an overview of Rust and how to start building smart contracts on Rust. We also have non-technical sessions, such as community management, Web3 marketing, and also soft skills, such as how to apply for jobs, how to write a CV, how to prepare for an interview. We organize frequently hackathons and challenges for our community where they can actually start building their portfolio, start building projects, join different ecosystems in the Web3 space with the idea, of course, to build their own products, projects, or to get a job in the Web3 space. And we also regularly send notifications to our community members if we have job openings from our ecosystem partners that advertise their job openings through us to our community. We have worked with some of the biggest names in the Web3 space, such as Celo, Gnosis Chain, Solana, and many, many more. And today is all about Concordium and the hackathon that we are launching together with the Concordium Foundation on our platform, techFiesta. techFiesta is the infrastructure platform for the hackathon where you get paid in crypto for your achievements, for participating in the techFiestas. You also get an on-chain verification of your experiences. So for everything you do, you receive a soulbound token which verifies your achievement and experience that you have done through techFiesta. And this soulbound token is held in your wallet, and with them, you build your on-chain CV. You can see on the screenshot here how it looks like. In the end of the day, you have like an on-chain CV displayed on our platform, holding all your soulbound tokens and verifying your trainings, your work that you have done, your hackathons that you have participated in. And it's a very cool way to present yourself to investors, to employers in the Web3 space, and show them that you have verified experience. And for this session today, you will also receive a soulbound token verifying your participation here. All right, so now about the hackathon. What is the key data for the hackathon? The start date is today, the 11th of June, and you will have until the 2nd of August to submit your project. The end date is the 16th of August, which means that until the 16th of August, Concordium will review the projects and will decide who the winners will be. And we will have a closing ceremony where they will announce the winners and also give feedback to the project. You can work in teams or alone during this hackathon. The most important thing is that you submit until the 2nd of August, and we will support you also in the team formation. All right, what is the task? The task is to utilize the Concordium ID to create full stack decentralized applications. Doris will tell you a little bit later on what is the Concordium ID and what use cases can be built with the Concordium ID, but some ideas here, some examples, what you can create as a decentralized app is that you can build a decentralized exchange, you can build a DAO, a dating app, or a mobile app. But of course, these are just ideas. You can build whatever you want as long as you utilize the Concordium ID. What are the rewards? So we'll have 3 winners of the hackathon. The first place will win 1,250 euro stable coins, which are on the Concordium blockchain. The second place will win 750 euro, and the third place 500 euro. As I mentioned, you will also get your own soulbound token for this session. And you can mint it. You will receive an email with the minting link. All right. So now I very, very quickly want to show you where you can find the hackathon before I give the word to Doris to introduce Concordium and give some more information how to build your application. Now let me quickly share my screen to show you how the techFiesta platform looks like and where you can find today's hackathon. All right. All right, so this is how techFiesta looks like. This is techfiesta.dev, and here you can find all the techFiestas. A techFiesta is a hackathon, a developer challenge, a workshop that we host. So here you can already see the IDConnect Concordium Hackathon. This is the name of the hackathon that we're just kicking off, and you can click on Start Hacking. And here you see all the information I just mentioned. I just want to say something. The price here is in USDC, but it's just because we currently cannot display the euro stablecoin of Concordium on our platform. So the price actually is in euro, but you can see this here in the rewards description. So basically, this is how it looks like. And then when you connect your wallet, you can register for the hackathon. But you see all the information that I have just told you. You see it here. You also see the submission criteria. There's a link to the code of conduct for this Concordium techFiesta hackathon. There is also a link to the events that we'll be hosting. For this hackathon, and after you register, you can submit your results here. All right, so this is from my end, and now I would like to give the word to Doris to introduce Concordium.
Yeah, thanks everyone for joining, and thanks for the nice introduction, Maria. Concordium is a blockchain, and it has some special features, and I will give you first an introduction about the facts and stats that we have on mainnet, so you get an idea how big we are and like what kind of things you can expect on a blockchain. So we have a transaction finality of like 2 to 4 seconds, so it's quite fast when you compare it with like Bitcoin or Ethereum. We have a EURE stablecoin, which you already know because the reward will be in EURE. And I think we're actually the only chain that has a native stablecoin, which is in euro, because all the other stablecoins are usually USD based. And I think that gives us like an advantage if you are building some dApps with the European kind of markets. And we have built our own Concordium BFT, like it's a consensus algorithm. It's actually the third algorithm that we already building. So we are have several times literally replaced the engine of the blockchain, and now we are like a very, very fast, very efficient Concordium BFT consensus algorithm. So I don't think we're gonna replace it anytime soon again because it's a big project. But I think we had a really, really good team who did this in the past, and that's why we already have this kind of transaction finality, which is that fast. Then our transaction fees are actually very low. So if you do a simple transfer from like just sending CCD, which is the native currency, from one wallet to another wallet, it's literally less than a euro cent. So it literally costs you nothing. And it's also interesting for you to know that it's pegged to the euro. What that means is when you send a transaction today and you send the same transaction in a few days, it will be exactly the same amount in euro that you have to pay. And this is even true if you compare testnet with mainnet. So if you have a testnet dApp and then move it to mainnet at one point, you literally can do all the estimation on based on the testnet values because they will not change. And the reason why we can do this is that we have not reached the full capacity of the blockchain yet. It's not like Ethereum that we are at the block limit and we cannot process transaction anymore. And yeah, we have still a lot of space, so don't worry, it will be very cheap for a very long time. And yeah, then in terms of how many smart contracts and accounts we have, these are the numbers. Interesting to know as well that actually accounts on Concordium are very special and a lot more complex to get. I will later explain to you. That means these accounts are maybe more worth than what you have on Ethereum because people actually have an ID behind it. You can do kind of proofs against these accounts and make some very interesting dApps. And in terms of like how much transaction the mainnet actually processes at the moment, it's roughly 5 to 10 transactions per second. So it's quite a lot for actually a not EVM-based blockchain. So we're quite high up in that field, I think. Okay, let's continue. Our ecosystem. So I think if you think about a blockchain project, what you want to do now for the hackathon, what would be good is you can check out our ecosystem, and if you think there's something missing, then I think it's a good idea for a hackathon that you can fill in. So I can give you a tip. For example, we don't have any lending platforms yet. So if there's something related to Aave, Compound you want to build, it's definitely something we would like to see. But of course, you can also come up with your own ideas. Yeah, and also you need to include ID, like I think it's a requirement that the Concordium ID should be somehow integrated into your dApp when you submit it in the end. Okay, now what is special actually at Concordium? So I already said a lot about there's something like an identity. What does it mean? So if you look at our website, it says something like this: Concordium is a science-based proof-of-stake public permissionless blockchain, and there is identity built into the protocol layer. So it means these identities are very, very strongly linked to the blockchain, much, much stronger than in many other protocols. I think in most protocols, you don't even have identities there. So a few points would maybe give you an idea how to think about Concordium is, okay, we have these identities, and it means that you need an ID, like a real world ID, like a passport, your driver license, to create an account. But because these information are then available, we can create CK proofs about this information and link them, or like can make dApps that react differently to different, I would say, users depending on their identities. It's a public blockchain, so anyone can run a node. If you want to build a smart contract, then you will probably have to use Rust. That's the best support that we have, and it makes sense at the moment to use Rust for the smart contracts. Yeah, we are science-based, so we have a cooperation with several leading universities in Zurich, also in Switzerland, and also in Copenhagen and Aarhus. And yeah, we have also a lot of connection to cryptographers there and building all this CK stuff. Yeah, and we're using proof of stake, so it's quite eco-friendly, and we don't use too much energy in the blockchain. Okay, let's look into how you can create an account on Concordium, because it's quite different probably what you're used to when you go to like Ethereum or Bitcoin. So okay, that's you here. If you want to have an account, what happens is if you're on mainnet, so on testnet it's a little bit different, but I'll show you later. But if you're on mainnet, you have to have a passport, like or something like a light driver license, or if you're in one of the Nordic countries, like they have e-passports, so you can log in with your governmental identity there, and then it's even much faster. So you just click a few buttons there, and then you're logged in. But if you're in a different country, then usually you need a passport or driver license or any kind of identification. And you send it to an identity provider. And the identity provider creates an identity for you. It's an identity object which is in your wallet, either on your mobile phone or like your browser wallet or so. So these information, your like personal information, will never leave like your laptop or your mobile phone. They will always stay locally. So we are not sending them or writing them on the blockchain. But what we do, we write a cryptographic commitment based on the information on chain, and this one will help us later to create these ZK proofs. But you don't need to be worried that like any of these information are written on blockchain in plain text or anything. Like it's really like we care about privacy, I would say. And once you have an identity in your wallet, then you can create like several accounts similar to any other chain. Okay, why do we have this? So, I mean, one thing is that we are Europe-based, so we need to follow the, I would say, regulation that is happening in Europe. And we have seen that a lot of regulation is slowly stepping in. And we think if we position us in a way that we could follow regulations in the future, based off whatever they decide on, like Concordium will have like a good chance to be like one of the biggest blockchains there. So what happens now, for example, if like you are involved in some kind of like illegal activity? So for example, you start laundering money on Concordium. So what can happen is this, a law enforcement can come with a legal warrant. So that means they have to come through a official court in, for example, Switzerland or any other, I would say, jurisdiction that is known, and have to bring or like start with like with this legal enforcement. And they bring this legal warrant to the identity disclosure authority. So at the moment we have 3 of them. These are like lawyers, and 2 out of the 3 we need. And if they accept this like legal warrant, they can decrypt a little piece of information on chain. And together it gives an identity number. And with this identity number, they can go to the identity provider, and the identity provider can then give the passport information to the law enforcement. So this whole process will happen off chain. So it's not that you will be shown your information on chain or anything. But if you do any kind of illegal things, there are ways on the blockchain that people can figure out who did what, and also can then link your accounts. So can figure out like which accounts you created and what transfers you did. Okay, now let's think about if you want to build on Concordium for testnet and for the hackathon, what do you need? So I give an overview and then go through the different processes. So I mean, one thing you would need is like the Rust programming language. So I would recommend you to like look there and install it. Then we also have a tool which we call Concordium. And this tool is there to compile your smart contracts. So first you write your smart contract in Rust, but you compile it, and the compiled module we then send on chain. So you will need this tool as well. Concordium can be downloaded from our developer documentation. And then you also probably need a wallet for most projects, I would say. So I would recommend you start with the Concordium Browser Wallet, or you can use the mobile wallets. We also have a desktop wallet, but I guess the browser wallet would be the easiest for the start. So I will show you how the browser wallet looks like. So that's the browser wallet. There's a link where you can download it. And yeah, I give you a few tips to get started as fast as possible. So just some information. Okay, the browser wallet, it holds your private key, and it has a link to the node. So that's how it communicates with the blockchain. And now here are a few tips to get you started as soon as possible. Yeah, I told you that if you want to create an account on Concordium, you need a passport. But the problem is like that's very annoying on a testnet, isn't it? Especially if you want to test things and maybe need a different identity. So what we have on testnet is actually you should choose the top identity provider, because it's one that we are running. It's only there on testnet, and you can be any identity that you want on testnet. So you can be Michael Jackson if you want. So if you click on it, you will literally fill in your passport information, and you can change your date of birth and whatever you want. And one interesting thing as well, that at the moment we mainly support this flow for people, so that you have to be a recognized person with an ID. But we also have flows for companies. So in a few months, we even will have a third identity provider who specializes in company creations. So if you have a company who is kind of registered in a local or like in a governmental registry of a country, you can also get an account and identity for a company. Yeah, another tip is also that you don't need to look for any facets. Like you can literally click on this button when you create your account and the first time, and then request CCD there on testnet. So don't look for a facet; it's already integrated into the wallets. And yeah, maybe also keep in mind that the usual flow is that you first have to create an identity, and then you can create an account. But usually there's no problems, because the onboarding flow in the wallets are already quite good. Okay, let's continue. Let's look into the second part that you need. It's probably a Rust smart contract if you want to build a full stack dApp. So that's Fairies. It's like a mascot of Rust. It will always open, like lift its hands like up and down, and it means if your code compiles or not compiles or has errors or panics, then it shows it with their hands. Okay, let's look into how you build smart contracts on Concordium. So that's you're the programmer. So you will write your smart contracts in Rust, in the programming language. And it will then, you will use this tool, Cargo Concordium, which I already recommended to you to download it. And you will use it to compile it into something what we call a WASM module. And this WASM module is the thing that you deploy on chain. So Rust is not the only language that can do this, but at the moment Rust has the best support, and also our tooling has the best support to like change Rust code into like a WASM module. So in the future we might have different languages, but for now Rust would be your go-to language, I would say. We now look at the life cycle. So what happens once you have your WASM module? So you deploy the WASM module on chain. And think about the WASM module a little bit. Like so far, we haven't executed any constructor in the WASM module. So think about the WASM module to be more like a factory on Ethereum, if you're familiar with that. And from each WASM module, you can create as many instances as you want. So you can create several smart contracts that are like kind of copies of the original WASM module in terms of logic. So the second step, what you would have to do, like this is one transaction that you do on chain. Then the second thing is you want to send an initializing transaction on chain, and then you get your own copy, and this is called a smart contract instance, which then has an address as well. And while you initialize the smart contract, you execute a constructor and like can set input parameters, whatever you want. And this is like how the normal usage of a smart contract will be from there. Then you have probably users who will update the smart contract instance based on some logic that you have defined in the smart contract. Okay, now look at the developer tools that we have. So I think I recommend to you like 3 things. You probably can start with our dApp template. It's like super simple. It has just a front end and a back end, like a front end and a smart contract. And we will show you also the smart contract tools that helps you to interact and read and write to the smart contracts. And then I give you some kind of a teaser how CK proof explorers look like, because I guess CK is not something that smart contract developers or blockchain developers do every day. And it's quite interesting how the interaction works and how it looks like. Okay, let's get started. I will go with you actually through the flow. So I recommend to use this dApp template. It's here, the link, and it's here. And what this dApp template has, it's very, very simple. So it has just the smart contracts folder, and it has a front-end folder. And then it also has something which we call CCD GS tool, which I would describe it as a glue. It combines the front-end and the smart contract folder in a way that it generates a smart contract client. And this client will help you at the front end to interact with the smart contract. So, for example, it will help you and tell you which contract functions you can call in the smart contract, and it will also help you to create input parameters with the right types, and will then give you an error if you try to like use the wrong types and the wrong functions. Okay, let's go through this first. I clone this. So I'm here in an empty folder. Okay, like if you're, okay, we have 2 folders. So let's go first to the smart contracts folder, and so let's look here. We have a cargo toml file. So maybe we look here. There we can always see a little bit more. So we have the cargo toml file. You describe like what kind of features and what kind of libraries you want. So these 2 libraries are from Concordium. So it's like a general it is a general testing library, and this is like our standard library that you will include in every smart contract. And now look at the logic. So it's a very basic smart contract. It's a counter smart contract. So it has a state where you have the counter. And then we have also a function to initialize the counter with number. And then we have an increment function, which will increment the counter. And we have a few function to see what value is stored in the smart contract. And there are two errors that can happen. So like either pass parameters error. So if you input a wrong type, so for example, you input a string instead of a number, or if you try to increment by 0, it will also reject and you get an error code. Okay, now look at how you compile the smart contract. So like I already said, Cargo Concordium is our tool. When you want to compile something in Rust, you write build. And then we want to output it somewhere. So we have the output flag and say we want to output module wasm version 1, this file. So version 1 just means that we had a version 0 smart contract at some point, and now we're at version 1. And then also a big tip, always try to include this schema embed flag. The reason is that this flag will embed a schema, and it will later help you a lot interacting with the smart contract on chain. It might, so depending, I can show you maybe here. So what the schema does, it uses the information that are written in this macros on top, and then transfer them or convert them into how the input parameters should be. And then this will help you at the front end, or when you interact with the smart contract, it will showcase, say, okay, this input parameter should have this form, and that's how it should be displayed. And so I would say compiling with this extra flag makes it sometimes a bit harder. It means if you have any bug in these kind of macros, the compiler will complain and say like, there's something I cannot compile correctly. But if you're able to compile it, which you should if you just follow our example repos, then it will make your life much easier later on if you integrate on-chain with the smart contract. Okay, let's try this to compile this in our example. So we are already in the smart contract folder. So let's compile it. So that's how Rust looks like if you compile it. It takes a little bit of time. You need to download all the libraries, but okay, it's done. And maybe I clear. Now you should see we have this extra folder, Concordium out, and there's this module wasm version 1. And later I will show you how to deploy it. But okay, now we look at the front end. Our next thing. Okay, the front end, what it is, it's like a normal, I think, yarn on Node front end. So you can just write yarn to compile the dependency. Okay, it will take a while, so let's see if there's any tips. Not really. Maybe one tip is here that you have to do this in the right order. So first install your dependency, then make sure that you execute yarn generate. Otherwise, some of the files are missing that the front end expects. And then you can execute yarn dev to run the front end. Okay. Now with yarn generate, we generate a client, which will help us to interact with the smart contract. And once you have executed yarn dev, we can look at the front end. It's a very basic front end, nothing special. Yeah, that's like the template here. So one interesting thing is that we read out from the client, we can read out information. So we already read out the smart contract name and display it here. And that's how you see that actually the client generation worked, and then we've got information from the smart contract to the front end. And of course, your task would be then like probably reading and writing to the smart contract to add these functionalities and add your app tab here. Okay, let's continue. But then we also have the smart contract tool. So there's a link where you can go to it, and it helps you to do several things. So it helps you to deploy and initialize the smart contract, which you have to do at the beginning to actually get it on chain. And then later you can choose to read and write to any smart contract, probably to your own smart contract if you just deploy it. But you can also, like, if you find a smart contract on mainnet or testnet, you can just look it up and investigate what's going on there. And the tool works on mainnet and testnet. And maybe one interesting thing is that smart contract addresses on Concordium, they look like this. So they have an index and a sub-index. So the sub-index is always 0. So it's more for the future that we have some ideas how to make some interesting features. And for that, we already have reserved like a sub-index. But for now, it's just the index which will increment. So that means the person that first deployed a smart contract gets index 1, and then the second person that deploys a smart contract gets index 2, so it increments. Okay, maybe we can look at it, how this smart contract tool looks like. So it's for developers, so it doesn't have a very nice UI, but it works well. So you can choose if you want testnet or mainnet. You can connect your browser wallet. And then it has these 4 boxes that I explained to you. So the first box is to deploy a WASM module. The second box is to initialize it. And then you can read and write to the smart contract index. And okay, let's do this first. Okay, yeah, we did this. I did this yesterday already, but okay. Yeah, it's already deployed, so I cannot show you this. Okay, let's look into the one that we just deployed now. Okay, I need to refresh. Okay, let's try this one. Okay, I already have deployed it, so that means you can only deploy each module once on chain. And if you try to deploy exactly the same one again, then it gives you like, there's no button, so you cannot deploy it again. But if you do it the first time and it's a new smart contract, you will have a button that you can click. And once you have deployed it, you can copy the module reference. And one thing you can do is like either you can derive it from step 1. That's what I always recommend you, because that means that all these things will be filled in. Or another thing what you can do is like you can derive it from chain. So for example, if you have a module reference, you can input it here and then derive it from chain. And then it will fill in your information. So for example, it's a my contract, that's the name of the smart contract. And it will also give you information about like that the smart contract expects an input parameter. So you probably should check this box and input it, otherwise your smart contract will revert. And it will, what I also showed you, like the schemas, because the smart contract has a schema, it displays you the information, okay, what do I expect here as input parameter? So it's an object, so you can select an object. And then let's initialize a smart contract. Say we set the counter to 5 when we started. And now let's initialize a smart contract. So we see the input parameter here again, and then the name of the smart contract and module reference. So it only takes a few seconds. Like I said, the finalization is 2 to 4 seconds on Concordium, so it's quite fast. So now you get a smart contract index. So this one is we just deployed. And yeah, so the other things you can do, like you can read and write to the smart contract. So let's do this first. You can input your new smart contract index that you just got. And I again recommend you that you always click this derive from smart contract index, because it will just make your life so much easier and fill in all the information. So it fills in the smart contract name. It will give you the endpoints it has. So we can look at a few endpoint, click and read from the smart contract, and we can see the smart contract state is 5. So we have set the smart contract counter to 5. Now let's also try to increment the counter and see how this looks like. So again, we derive from the smart contract index, so we don't need to fill in anything. Okay, we need to increment. Again, it gives us a warning, say, oh, I expect an input parameter, so please give an input parameter. Okay, let's increment it by 2. Let's update the smart contract. And it will give you a response once it's updated. It's very fast. Okay, it was successful, the transaction, and now we can read again and see that our counter has updated. So it's 5, it should be 7. Ta-da, updated to 7. So that's how easy it is to like deploy a smart contract and interact and read to smart contracts. Okay, let's give you also some additional tips. As I already said, it's very much recommended that you input the schema. And to show you case you this, like I have a smart contract. So this smart contract we just had, it's like the same one, or like it's the same one that we deployed here. So this one has a schema. So you have seen it is very easy to interact with it. And let's look also on chain how the smart contract looks like, how a smart contract with a schema looks like. So we are in testnet. So you can also in the Block Explorer look for the smart contract. And when you go to the smart contract, you can go to the module reference. And here you see there's a schema field. And when you look at the schema, you see all the information from like how the input parameters are, how the return parameters are, and how the events are, if there's an event. And it helps you to display the raw bytes, which usually are coming from the smart contract or sent to the smart contract in a meaningful manner. So now let's look into what it looks like if we don't embed a schema. So here we have a smart contract that has no schema embedded. And now I show you how ugly this looks like. So I derive this one from chain again. So you already get an error, there's something, the schema is not there, and it makes it hard for it. So you already get some information, so it still figures out what's the smart contract name. It also figures out what are the entry point names. But now there's a big difference. So if I try to read something from the smart contract, you see the only thing I get is bytes. And there's no way for any tool to figure out what these bytes mean. And it's very hard to decode, I would say. So I just recommend you use a schema. And we can also look into the Block Explorer, how a smart contract looks without a schema. So if you go to the module, then you see there's no schema type tag. So that's how you can check if the schema is included or not. Okay, that's one tip I can give you. So use schemas if you can. And then maybe something else to look into is like all the error codes that you can get. So often you get these error codes, -1, -2, -3. And these are error codes which come from the smart contract itself. So if you look into the smart contract here again, here we annotated it. So the errors is an enum in Rust, and enums in Rust are defined at like the top one, it gets the value -1, -2. So usually in enum it would be 0, 1, 2, 3, but because we know that it's an error, like we recreated it and said like, okay, errors should be defined as follows, that like the first variant gets -1, the second variant gets -2. And we can check this out at the front end as well. So let's try to create this arrow here, so increment by 0. Let's look up the smart contract index again. So this is the smart contract that I deployed yesterday, which is the same smart contract, same logic. So we derive it from chain again. Let's increment. And now we try to increment by 0, which is not allowed. Okay, let's increment by 0. And then you get these -2 error codes, and that's how you can then figure out what's wrong. Just look into your smart contract code and just count from the top and then figure out what it means, the error. Another error you can get is like these type of errors, and they come from Concordium standard. So if you Google Concordium standard, it's a library that we use and the blockchain is using, and it has a list of error codes that you can look up. So the most common error codes you will probably encounter is this not payable error. All the other ones, it's very unlikely that you hit them. But it means if you, for example, try to send CCD to a smart contract endpoint and it doesn't expect you to send CCD, then you will get this error, like not payable error. Okay, let's look the other last error that you can get. So there's also, if you by chance work with any of our SIS2 tokens, so the SIS2 tokens are like ERC20 or ERC721 tokens. So they're kind of equivalent or similar to like the Ethereum token standards. And these token standards, if you have them included in your project, then they can also throw errors, and they have the form of something like 4200. So you can look up them, and it's only, I think, 3 errors, but you can encounter them. So if you have this error code, it means invalid token ID, insufficient funds, or unauthorized. I think these are pretty much the only errors that you can run into it, and I hope you can decode them now, and it will make your life much easier. Okay, let's go to the last thing. That's very special, so it's more like a teaser, and that's how a CK-proof Explorer looks like. So I already said to you that we have identities in the wallets, and this identity has information, and we can generate CK proofs about them. And we built an Explorer for that, so people can play around with it and see how to generate such proofs and verify them. Okay, let's look into the flow first, how this can happen and how it works. So like you have the front end, you create your request. So for example, you say, I want to prove that the person's over than 18 years old. This request is sent to the wallet. The wallet will have a pop-up and you can either approve it or like reject it. So of course, if you don't want to reveal the information, then you can of course reject it. Like the front end should not get information if you don't want to reveal the information. But if you approve it, then a CK proof is generated, it's sent to the front end. And the CK proof is then sent to the backend. And the backend looks up this cryptographic commitment that was written on chain at the beginning when the account was created. And together with this information, it can verify if the proof is valid or not valid and send this information back to the front end. So that's the basic flow how CK verification works in the Proof Explorer. And I just show you how this looks like. So that's our Proof Explorer. It's for developers to test out. So it's not a front end for users. So it doesn't look that nice. You can connect your wallet. So I'm connected now. And this here in the middle, that's the proofs you can generate with the identity that you have in the wallet. You also have Web3 identities, Web3 credentials, but these are a bit more complex. So there's also tutorials we have about them. So I will not tell you too much about them today, but we will look into these basic identities that you have from your account creation. So let's first prove that we are older than 18. So that's we can do. Okay, we have an error. We first need to select an issuer. So remember, we used the Concordium testnet identity provider, which was the one that allows you to create fake identities. Okay, let's clear. So we have two. Okay, let's have one statement. So what we want to prove is that our date of birth is in this range. So we have a lower and upper range. These are Unix timestamps. And we can click on proof. And then the wallet will pop up. And you can click on more information, and then you have the information what you actually will reveal. So you will reveal from this identity, from this account, that you're older than 18 years old. And I can approve it. It takes a bit. The proof is generated. It's sent to the backend, and then the backend checks it, and it sends it back to the front end, and it says the proof is okay. Now let's do the opposite. We want to prove that we are younger than 18, which we cannot because we need to clear last messages. Because like our identity is, I think, 30 or 40 years old. So we cannot prove this. And now we get a different thing that says unable to verify. We can click on here, but we can only reject it because our wallet is not able to even generate such a proof. An important thing is as well that whenever a request is sent to the wallet, the wallet needs to either reject or approve it. So the wallet waits until the user is doing something. It will never kind of already reject and say, okay, I don't have anything in it that could even generate such a proof, because it would leak information. So think about it, if the front end would just brute force and ask, are you older than 1? Are you older than 2? Are you older than 3? And if the wallet would react, then you would figure out how old the person is actually. So the wallets are in a way built that they will always wait, and the user needs to either reject or approve, and in that way you cannot brute force any information. And then you get here, like, could not get proof generation was rejected. And a few other things that might be interesting, what you can do with these proofs is, like, for example, you can create set membership proofs or not set membership proofs. So you can prove that you are in the European Union or you're not in the European Union. So let's look how this looks like. So we are asking, is your nationality from the set of these countries? And our nationality is from that set. So we are from Denmark. And it even says you, like, the proof is about nationality, are you from the European Union or not? And we can create such a proof. Yeah, it might be interesting that you can build such proofs around our identities. Yeah, please check out this Proof Explorer, play around and have fun with it. Okay, let's continue. Okay, now I want to give you some help how you could think about an interesting project that you want to build during the hackathon. So I will give you one interesting project that we have used in the past for another hackathon. So you will get all the code to create this kind of a dApp already in the end. But I think I want to help you to think about a good idea. And let's think about what the problem was and how we created a dApp around it. So that's you. You like singing. And then you're also a big fan of this Eurovision Song Contest. And then if you remember a little bit, okay, how does this contest work again? Like, okay, you have to vote for a country, but there's a specific rule, isn't it? Like, if you vote, you're not allowed to vote for your own country, just because otherwise it would be unfair. Big countries in Europe would have more votes. So there's a big rule we need to follow. But how do we do this? Like, how do we figure out if somebody votes in an app that this person is not voting for its own country? So you think about it, and then you're like, okay, there was something like Concordium and its identity layer. So what is if you use it? So first, when we build the dApp, what would you have to do? Like, okay, we need a voting contract, we need to initialize it with some information like end time, election description, voting options. And then we want the users, the Mr. X, to vote for it. So they would input a parameter, the country code that they want to vote for. But then we need to implement a special rule. And how do we do it? Yeah, we do this with the CK proof. So we check that the country of the voter is not equal or not in the set of the countries that he wants to send into the as an input parameter. So we do this check off-chain. It's again like a CK proof, similar to what I showed you in the CK proof explorer. The backend would check the CK proof if it's valid, and once it's valid, it would sign it. Like there's a secret, a private key at the backend, and give the front end a signature. And then you would add the signature to your input parameter, and the smart contract would check the signature from the backend and only allow this transaction to go through if it has included a valid signature from a backend that you trust that you're running and where you do your CK proof verification. So that's pretty much how you would do a voting contract by having additional restriction on how people can vote. So one example would be, for example, the European Union election. There you can also do a very similar setup, just and you have probably some restrictions where you can only vote for your own country. It's kind of the opposite voting restriction. Okay, all these workshop materials you can find there. There's already backend build, front end, and smart contracts. So you can look at it and maybe it helps you for your own project. Okay, let's think about some other ideas, what you might want to work on, and I hope it helps you. So one thing could be like something related to frequent flyer cards, where you use the identities to figure out it's maybe the same person that's already booked a while ago. You can think about employment relationships. So maybe we build a front end where you can only log in if you're actually from that company. Education certificates is something interesting that you might want to store or like link to an identity. And then these things are usually questions that come up in business relationships, and the Concordium ID would be very useful. So there are a lot of businesses, gaming, alcohol, where you need to check if people are older than 18. Then if you interact with social media, it's always the question like, who is this really? Is it actually the person that they claim to be? And maybe you want to compare this to the full name that's in the identity in the Concordium blockchain to make sure it's actually the person that you expect to interact with. And you can also think about event tickets. Maybe there's something with identities you can do. Okay, now I give you a lot of resources where you can probably start reading, and you find also a lot of example dApps to build on. So our developer documentation is probably a good way to learn more about Concordium, our technology. And we have several tutorials where you can look through if there's something you want to start with. We also have a Concordium Academy, so that's a little bit more like coursework. So they have like 4 or 5 courses, and after each course you can do an assignment, and if you do the assignment you get an NFT reward minted to you. And it's a little bit more like coursework if you like to learn like that. Then that starter template I already showed you. It's a super simple starter kit to literally get going. We have many dApp examples. The top ones, they are a bit more complex. So usually they have even backend indexes and whatnot, like can be quite complex, and some are a bit more easier. And then we have a bit smaller dApp examples, usually integrated into the browser wallet under this link if you want to check them out. And we have smart contract examples that you can explore. And then also we have this deploy, initializing, read and write tool that I showed you already, and our block explorers. And here are additional resources. I think you probably don't need it too much. Like we have public nodes available on testnet and mainnet, so you probably don't need to interact with it, but we have a tool. It's called Concordium Client, and it allows you to interact with a node directly. So it's a little bit like if you know Infura or Alchemy from Ethereum, it's a little bit like that. You get an API endpoint. So this is something like an API endpoint, and you can call it and get information, like raw information from the blockchain. Yeah, there's a general support where you can call questions after the hackathon. I think for the hackathon, you have extra channels and different platforms. So it's more for after the hackathon. If you have a lot of different SDKs, I just linked the Node SDK here because I think the Node and the Rust SDK is the best one. Like they have the most features and the most complete. We have a lot of other SDKs like Java, Go, Swift, but these SDKs are usually developed based on the features that people request us. So they might be don't have everything that you want to have in the beginning, but probably for basic things, there's everything there. And we have many hosted front ends, so you can click around, play, and see what's possible. Okay, and I give you also like a bit of a teaser what you can do after the hackathon. So what's next if you want to continue? So we have this Concordium grant project, a program where you can apply with your project, and if you get it, you will literally get paid for continuing working on your project and making it a production-ready project. Then we have also something new, which is these announced ecosystem grant projects. They are not live yet, so you would have to follow our social media links to see. They will be announced in a few days. There's already some kind of publicly known but secret repo where you can check them out. But I would say like you have to follow our social medias to see where the official announcement is and where the official kind of requirements are. And what these announced ecosystem grant projects are, it's a little bit that we give out a task and then say, okay, for this task, we would pay you 1,000 USD or EUR if you complete it. And if you submit a PR and we review it and merge it, you get paid for that. So we do things that we, projects that we think would benefit for the ecosystem, we will announce as an ecosystem grant project. And then we also have continuous tech support. So even after the hackathon, you can reach out to us technical people and ask questions. Yeah, any questions? So.
All right, thank you, Doris, for your presentation. And thanks for suggesting so many different projects. I wanted to mention that we have also integrated the Concordium ID into techFiesta for the participants here also to understand another use case. For example, in our case, we're using the Concordium ID to verify the country of origin or where your passport is from, because some of the sponsors of hackathons or techFiestas that we organize have regulatory requirements and restrictions in terms of where participants should come from. And maybe just a second, Doris, maybe you can stop sharing your screen so I don't see myself. So in this case, we utilize the Concordium ID. So when people register for a techFiesta, we know where people are from. And when a sponsor has this requirement that they do not to let certain people from certain nationalities to join the hackathon, we just restrict them from participating and from registering. So this is one of the use cases we use the Concordium ID for. And another one, I mentioned to all of you that you can mint your soulbound token for participating in this session, for example. And these soulbound tokens are actually held in your Concordium ID. I want to actually quickly show maybe how that looks like. Just a second. I will show you how it looks like because this is actually super cool. I will share my screen. All right, so this is the page of the hackathon, but I'm opening now my Concordium wallet. And you can click on collectibles, and here are all my soulbound tokens that I have had or I hold, right? And then you can see your soulbound token here, and this is in your personal Concordium ID, a soulbound token for yourself. It is not transferable. It is in your ID and connected to your ID. And this is what I meant with you're building your own CV, you're building your own portfolio, because by collecting these in your own ID, it is connected to you as a person. So you can showcase this, that it is actually you that has done that. And this is very different than just collecting POAPs, right? A POAP is something very different than a soulbound token that is attached to your ID. Yeah, so I really like the Concordium wallet because it has all these amazing functionalities. And I just wanted to show how that looks like in our use case, right? This is what we have built with the Concordium ID. But as Doris mentioned, there's so many other use cases that you guys can work on and think about. And I'm really excited to see, yeah, what's going to come out of this hackathon. And yeah, so now we're open for questions. You can either put your question in the chat here, or you can unmute yourself. I would like to say, someone asked how do I join a team? So you can join our Telegram, and there we have an Excel sheet for the team formation. So if you don't have a team, you can add yourself there, and you can see with your skills, and you can see everyone else who is still looking for a team. And you can just write these people either an email or on Telegram. They have left their Telegram handles as well. You can see their skills in the Excel sheet, and you can just write them a message if they want to form a team with you. And then you can form teams. And other than that, you can also write in the Telegram group that you're looking for a team, and shortly write a description about your skills. So other people that are looking for a team know if they can team up with you. The best team formation would be people with different skills, right? So maybe a front-end developer, back-end developer, maybe also someone to help with, let's say, more of the business side of the use case, creating the presentation, maybe creating a video that showcases what you're going to build. It's going to be even amazing if you can already onboard some community to use your application until the end of the hackathon. Yeah, to see what you're building. Yeah, so this is about the team formation. So you guys, are there any other questions? How will you be notified if you're restricted? Well, yeah, so Bogachan is writing it, it's the code of conduct, yeah. Who is restricted? You can see the code of conduct, it's in the page that I just posted here. It's linked there. We'll see what the others will build. I'm really excited about that. Perfect. So thanks everyone for participating in the session. Thank you, Doris, for your presentation. And if you guys have any questions, I'll write in the Telegram group and we'll answer them. We'll also help with team formation. So please write in the Telegram group if you're still looking for a team, and we'll help you. Thank you and have a great day.
Yeah, thanks everyone, and have fun and just build something you like.
Bye.